Okay, this lecture video is going to be on chemical symbols. So in general, a chemical symbol looks something like this. So in this model, X represents the element symbol, and this is what we'll be finding on the periodic table when we start looking at it. A represents the mass number, and Z represents the atomic number. So let's look at a little more detail as to what the mass number and the atomic number are. So first of all, the atomic number Z is equal to the number of protons in that particular atom or that particular element. And for a regular old plain old element, or an atom of that element, which is neutral, we know that the number of protons must be equal to the number of electrons. So the atomic number for an atom tells us the number of protons and the number of electrons. I don't know why I'm writing in red. Let's switch. So the mass number, on the other hand, A, is equal to the number of protons plus the number of neutrons, right? Because those are the only two subatomic particles that contribute to the mass of an overall atom. So that means you can solve for the number of neutrons by taking the mass number and subtracting the number of protons, which you get from the atomic number. So from the mass number A and the atomic number Z, you can identify all the subatomic particles from the chemical symbol. So let's do an example. Let's go to our carbon-12 that we were working with in the last lecture video. So carbon-12's chemical symbol looks like this. So from this information, we can use the atomic number Z to get the number of protons. So that's equal to 6. And since the number of protons is equal to the number of electrons for a neutral atom, the number of electrons is also 6. Then we can use our mass number, which is 12, to get at the number of neutrons. And we know that that's going to be equal to A minus Z, mass number 12 minus atomic number 6. So that gives us a total of 6 neutrons for carbon-12. Let's look at an isotope of carbon. Let's look at carbon-14 now. So again, the atomic number hasn't changed because it's still carbon. So the number of protons is equal to 6. The number of electrons is equal to 6. And now the number of neutrons is equal to 14, which is the mass number, minus 6, which is equal to 8. So we can see here in carbon-14 we've got a different number of neutrons. Let's go ahead then and look at some chemical symbols for ions. So let's look at the chemical symbol for a sodium ion. So Na is the element symbol for sodium. And its chemical symbol will look like this. So now, looking at the number of protons, we see that, changing color here, that the atomic number is 11. So the number of protons is equal to 11. The number of neutrons, we'll get to electrons in a second since this is an ion, the number of neutrons will be A minus Z, which is 23 minus 11. So the number of neutrons is equal to 12. And the number of electrons then is going to be equal to 10. And I'm getting that by taking the atomic number or number of protons, which was 11, and I'm subtracting 1. That was nice. I'm going to put that on your quiz maybe. 11 minus 1 is 10. So 11 was the number of protons, and 1 is the number of electrons lost because this is a positively charged ion, has a charge of +1, it's lost 1 electron. So then there must be 11 protons and 10 electrons, which gives an overall charge then of +1. Let's look at an example then for ion. So in this example, we'll look at oxygen, which the oxygen anion has a charge of -2. So its chemical symbol looks like this. So the number of protons we get from the atomic number, that's 8. The number of neutrons then would be the mass number 16 minus the atomic number. So that's 8 neutrons as well. Then if we want to look at the number of electrons, since this ion has a charge of -2, that means it's gained 2 electrons. So since it's gained 2 electrons, if it started out with 8 electrons, because that was the number of protons in the neutral atom, so it started with 8 electrons, it gained 2 more electrons. So oxygen with a charge of -2, the oxygen anion, has 10 electrons total.